Oh, wow.
So we are going to talk about, we've been talking about radicals. We've been talking about simplifying radicals. We've been talking about adding and subtracting radicals, right? We haven't gotten into multiplying radicals yet. I'm saving that for, you know, maybe, I don't know, maybe next week, maybe later this week. But I wanted to show you where you use radicals, and just to give you an example. And the Pythagorean theorem is a perfect example of where you would use radicals. Pythagorean theorem is...
Well, is it the one with the big fancy swoopy?
Isn't it a squared plus b squared equals c squared?
It's a squared plus b squared equals c squared. And what is this for? Does anybody know?
A triangle.
Okay, Kareem. So what kind of triangles?
A right triangle.
Daddy, what is that
Right
last
triangles.
word?
This is for right triangles. For right triangles.
Hey, Dad, what does that last word say on the board? I cannot read it.
Theorem. 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 For what did I say? Triangles. Now I could write triangles, but in geometry there's actually a symbol. Instead of writing the word, you can do this. You can write a triangle, and you can put an S after it if you want. For right triangles, okay? And so if I had a right triangle, all right, this is a right angle. You guys all know that when you see that little box in that corner? That means it's a right angle. If it was just a curved thing, it doesn't mean it's a right angle. Like sometimes you'll see this. Oh, sorry, it's not a right angle. We don't know if it's a right triangle. So you can't assume it. But if it has that little box there, like a square, then you know, oh, that's a right triangle. That means this is how many degrees? 90 degrees. So we know that right away. That's 90 degrees. Wow. And what do we know what 90 plus this equals? 180 degrees, right? Every triangle in the universe, not just on Earth, in the universe, if you add all the angles together, they equal 180 degrees.
What if like an alien race called circles triangles?
Now, that is the first time anybody's asked me that question, and I don't have an answer for it. I'm like speechless, Liam. You have totally stopped me in my tracks. Okay, so now you have, with a right triangle, you have two legs. You have two legs. And you have one hypotenuse. H-Y-P-O-T.
Hypotenuse.
Is there an H in there? Hypotenuse. I think that's how you spell it. Two legs and one hypotenuse.
Hypotenuse is the longest side, right?
Hypotenuse is the longest side,
that was
right?
like negative 2 legs.
Longest side. Right? The other way you can think about the hypotenuse, it is also opposite what?
Opposite to the smallest angle.
It's opposite the largest angle.
Opposite to the right angle.
Yeah.
Right?
Well, the right angle is the largest angle.
By the way, that's how you write angle in geometry. So, right? So it's opposite to the right angle. Here's the right angle. What's opposite the right angle?
The hypotenuse.
There it is, right there. This is my hypotenuse.
That's great.
Hypotenuse. And my legs are connected by the right by the right angle. I'll say adjacent. Do you know what adjacent means?
Oh, I thought you said adjacent.
Adjacent to right
Yeah, I thought you
angle.
said adjacent too.
Adjacent, like Elizabeth is adjacent to Sal. Sal is adjacent to Tiana. Tiana is adjacent to Emma. You know, right next to. Adjacent means right next to. So the legs are always adjacent to the right angle. So if you ever want to know what the legs are, this is a leg, right? How do I do this? Leg, leg, right? Okay. Now we're going to get to our theorem. This is a very cool theorem.
So wait, how does this tie into radicals?
I'll show you in a second. But here, let me just...
because your answer is the square root.
Yeah, right. So this what Pythagoras said is, if this is A is one of the legs, and B is one of the legs, and C is the hypotenuse. Okay? A, B, and C. What Pythagoras figured out is that A squared, if I multiply A times A squared, and I add that to B times B, or B squared, that would equal C times C, or C squared. And this is what he actually did. When you think about A squared, think about, like, right, that's a square. A times A, right? This would be A squared, right? A squared would be your area, right? Your area of a square would be, if you have side A and side A, it would be A times A is A squared. That's your area. Watch this. I may not be able to do this very accurately, but I'll try. Right? So that's supposed to be a square.
Yeah, that is a good square.
Right? And that's supposed to be a square. And this is supposed to be a square as well.
Well, why is that so big?
All right? So look. So this is my C squared, right? Because this is my C. So this is my C squared. This is my A. So this is going to be my A squared. And this is my B. So this is going to be my B squared. He's saying, this is what Pythagoras was saying. He said that the area of this little box plus the area of this little box is equal to the area of this huge box, right? Now, that's a little hard to believe, right? And there are proofs, and he can, we could talk about it, and I could show you how he came up with that, and everything. I'm not going to go there today, but I'm going to make you believe it right now. But actually, in a few minutes, I'm going to show you something that will prove it. It's it's very cool. I just don't want to. Don't let me go past. I need to stop at 5 of, okay? No matter where I am. So this particular theorem is extremely useful. Let's say I had now I'm going to just erase all my mess ups here. Let me just get all this stuff so I can start from scratch with a triangle. So let's say I have, whoops. Okay, let's say this is 3, let's see, yeah. Let's say this is 3 inches. And this is, well, yeah, whatever. And we'll say this is 4 inches.
No,
it's not inches though, right? It's not, maybe I shouldn't say inches. I don't know. 3 units. We'll just say units. Whatever, we'll leave out the units. We'll just call them units, right? There's 3 units and there's 4 units, and we're asked to find the 3rd unit, right? The hypotenuse, the length of the hypotenuse. So I want to know how long the hypotenuse is. So I go to my formula. It says A squared plus B squared is equal to C squared. And then I go, okay, A is 3. So 3 squared plus, now B is 4, so 4 squared is equal to C squared. So what's 3 squared?
21. It's 9.
What? Yeah, 3 squared is 9, right? Plus 4 squared is 16 is equal to C squared. Now, what's 9 plus 16?
25.
25. 25 is equal to C squared. Now, I know what C squared is, but I want to know what C is. So, Indu, what do I do?
Wait, it's the square root of
yes.
that.
So, I want to know well, I haven't talked about square roots of variables, but square root and square are exactly opposite each other.
Yes.
They're opposite operations. Like if X was here last night and he was all by himself, right? Mm-hmm. And somebody came along and they added 2 to him. How could I undo that? I could subtract 2 from X, right? I could undo what they did. If they came, he wins. He's winning. I'm sorry. Say it again. What? Say it again.
If there's an exponent on a variable,
yes.
Can you square root that variable and then square root the other side of the equation?
Yes.
Yay.
Yes. So since C squared is exactly the same as 25, if I square root C squared, I have to square root 25 as well. So I'm going to square root.
5 equals c, right?
So 5 is equal to c. Whoops. 5 is equal to c. So what we just figured out using the the Pythagorean theorem, we figured out the length of side c. Yes, Indu.
Isn't that like some kind of weird, like fancy triangle? Isn't that triangle supposed to be all fancy?
Yes, this is actually I have used this triangle. You will use this, I mean, if you were a builder, you will use this in real life. Sometimes you don't have a right angle, right?
Mm-hmm.
Like you don't, like if I was building this cabin for a friend, yeah, up in Chupadero, up in north of Tsuki. And so I built this, you know, I don't know, 12 by 12 cabin or something. And I had to lay the foundation. You know, I had to put in pillars, and you know, because it was on a hill, so I had to have the pillars so that I could make it level. And I had to have a right angle. But you know, I didn't have. I mean, I don't know. I just didn't. You know, a little square isn't very big. You know, like when you have a little square like this. You know, God, is that going to really, you know, work? So what I did is I got a piece of I got a tape measure, and I measured 3 feet, and I made from a point, and then I measured 4 feet from a point, and then I measured 5 feet, and I connected these 2 points. I moved these points in until they were 5 feet apart. Does that make sense? And by doing that, I knew I had a perfect square. Isn't that cool?
Yeah.
So I used it. I used the Pythagorean theorem when I was building this cabin. So now sometimes though the unknown is not the c, and sometimes they're not going to work out as a perfect, you know, c equals 5. There might going to be So let's do one where it says instead of c.
Do we get to do Pythagorean theorems for homework?
Yes.
Oh no.
Yes.
No.
So this is a, and we'll say we don't know what a is, and we'll say c is 9, and we'll say b is 7. Okay, so we've got a squared plus 7 squared is equal to 9 squared. So I suddenly have a squared plus 49 is equal to 81. So I'm going to subtract 49, right? Because I want my a squared all by itself. And then I have a squared is equal to, I don't know, what is that? 11, 2, 32. Yes. A squared is equal to 32. All right, but I want to know what a is, not a squared, so I'm going to square root a squared. Now, notice square root and squares are opposite operations, so basically they cancel each other out. So all I'm going to have is a. I've got to square both sides. A is equal to square root of 32. How do I simplify square root of 32?
Do we have to simplify it, or can we just leave the square root of 32?
16.5. Yes, you should make us simplify it.
I'd say simplify it.
Okay.
Because if you can. If you cannot, then don't, right? If it doesn't have a perfect square in it, like if it was a square root of 33, you wouldn't be able to do anything. You'd have to leave it like that, right? Square root of 32, though, is going to be the square root of 16 times the square root of 2, which is equal to 4 times the square root of 2.
So then we have a equals.
Yeah.
Wow.
All right? Isn't that cool? All right, so I just want to quickly, I'm going to stop the lecture so I can show you this video.